All right, this video is for lesson 7-7 homework. Same routine we've been doing, we're just doing shape this time. So trapezoids have a little bit different rules than everything else. All right, so trapezoid is still a quadrilateral, 4 sides. It's got exactly one pair of parallel sides. So one of the pairs are going to be parallel, the other are not going to be parallel to each other. The parallel sides are called the bases. The non-parallel sides are called the legs. It's important to be able to know which ones are the bases, which ones are the legs, especially when it comes to finding the area of these things, okay, which we're going to do in the next unit. All right, then we got a special trapezoid, and it's isosceles. So if the legs of a trapezoid are congruent, so like on this one, see those little congruency marks, and it says both these sides measure the same, we've got an isosceles trapezoid, okay? So in an isosceles trapezoid, the base angles are congruent. So that means these angles down here, these two would be congruent to each other, and then these two would be congruent to each other. If a trapezoid has one pair of congruent base angles, then it's isosceles. Meaning if one of the pairs, if these two angles are the same, it automatically means these two are going to be the same, and that these two sides are going to be congruent. And then in an isosceles trapezoid, the diagonals are congruent. So from corner to corner, those are going to match up. All right, so the angles in these. So the diagonal angles. We've got the triangle going on again, but this says angle ADO is the same as BCO. So ADO is this little piece up here. It's going to be the same as this little piece over here. So if this is 79, then this one's going to be 79. And then if we know that this one is 79, all 3 angles, we've got a triangle. We can find the missing angles. So we can use the triangle rule. We also have a mid-segment in these. So the mid-segment of a trapezoid connects the midpoints of the legs. So halfway across each leg is where that mid-segment goes. It's going to be parallel to the bases, and then the measure of the mid-segment is half the sum of the length of the bases. So I can take these two sides, these two parallel sides, add them up, divide by 2, and that's going to be the length of the mid-segment. So if we've got angles created, we can find missing angles. So if this angle up here is 117, we do know, let's see if I've got one of those. I don't have one of those yet. All right, LWV plus WLK equals 180. So LWV, this one, plus WLK, this angle here. If we add those two together, it's going to equal 180. Okay, just like this angle, I don't know if that one works that way, but this one does. The mid-segment, it'll add to 180. So we can find the missing angle. If we know what this one is, then we can find other missing angles. We can find what this one equals right here. It'll make more sense when we do it, okay? All right, diagonals. Diagonals are congruent. So if we know the measure of one diagonal, we know the measure of the other diagonal. They're not bisected. So in the other shapes we've done, the two little pieces have been congruent to each other. That doesn't work in these. But since the full diagonals are congruent, the little piece of this one is going to be congruent to the little piece of this one. The bigger piece of this diagonal is going to be congruent to the bigger piece of this diagonal. And then I think that's it for this one. Okay, so let's look at the homework. So first thing we're going to do is we're going to find diagonal measure. So this one says OH is 74 feet. So that's this piece. And then it says OF is 21. That's this piece. It says find the length of EG. EG is the other diagonal. The diagonals are congruent. So if I know the total length of this diagonal, I know the total length of this one. All I have to do is add those two pieces together. So 74 plus 21 gives me 95. So on this one, RT is 27 inches. That's the full length of this. Over here it says OQ, O to Q is 8 inches. It wants to know the measurement of this piece. We know the total length of the diagonal. If RT is 27 inches, then OS is 27 inches. Okay? So diagonals are always congruent. Okay. Here's where things kind of get a little bit more complicated than what we've been doing. Are these mid-segment rules. It wants to find the value of X and then find the requested side length. So here we've got, I know it's kind of hard to see because it's sideways, we've got YZ as a base and we've got XW as a base. So on this one, 1/2 of YZ plus XW is going to equal the mid-segment. So take the two bases, add them together, divide it by 2, and you get the length of the mid-segment, which is DC. It's easier to write it out like that and then go back and fill in your pieces. So YZ is this one. It's 84. XW is this one. 3X plus 11. And then DC is this one. 10 plus 4X. If you can get it to this point, the calculator does the hard work for you. So let's see. We can do menu 3-1 and then type it in. Parentheses and all. Some of you guys started to see last week how dropping a parenthesis really changes a problem. And we get X is 15. So this wants me to find CD. This is CD right here. So I'm going to take my X value and I'm going to plug it in for this X here. Woo-hoo. And so that one's going to be 70. And we know it's going to be feet, it tells us. So on number 4, your relationship, like what I wrote for this one, I will write that relationship out for you. You have to fill in the blanks. So 1/2 of CD plus BA is going to equal the mid-segment, FE. Go plug your pieces in, solve for X, take your X value, and figure out what AB measures. All right, angle measures. So consecutive angles are going to be, they're going to add up to 180. Okay? This angle plus this angle is going to add up to 180. So I can take those two pieces, X plus 95 plus 81 plus X, and set them equal to 180. And then I can do menu 3-1 on it. This wants to know the measure of angle C. This is angle C, the X plus 95. So I want to take that X value and I want to plug it in for that X. So 2 plus 95 is 97. Ugh. Trying to figure out how I want to do this next one. Or how I want to explain to you how to do this one. All right, with the diagonals, with a situation like this. We've got the two diagonals, and then we're talking about these little pieces up here. These diagonals are going to split they're not going to split the angles perfectly, but since they're congruent, these little angles that they make on the inside are congruent to each other. So when we have these two pieces like this, we can set these equal to each other. And then we can solve for x. What this question asks, though, what is the measure of COF? C to O to F. That's this piece right here. So before I can do anything, I got to plug 20 into one of these. It doesn't matter which one you plug it into. It's going to be the same. Okay, so I got 36 there. If I plug a 20 in there, it's 36 as well. What we have is a triangle. So we can find this little piece by using the triangle rule. We can take 180 and subtract the two angles that we know. So 180 minus 36 minus 36. And that'll be 108. Just pay attention to what they're looking for, what they're asking for. All right, and one like this. Notice the congruency marks here and here. That means this angle is equal to this angle. So you have to pay attention. If they give you those marks, that tells you what to do. So we can set those two equal to each other. And I can do manu 3-1. Comma x, and x is negative 12. What this one wants is it wants you to find VUS. It wants you to find what this angle measures. So you can take this value and you can plug it in here. Find what this angle measures. You know what this angle measures, and use the 180 rule. I'm going to leave that last piece for you to do. All right, mid segments. How these mid segments work is when we did the parallel lines. Remember when we did these? And we could tell which angles were congruent, like, oh, this one and this one match up. Or this angle and this angle measure the same. These mid segments kind of work the same way. Okay, because they're parallel. Because all three of these lines are parallel. So if this angle down here is 2x plus 95, so's this one right here. This one is 2x plus 95. 2x plus 95. And then we know with that mid segment that this angle and this angle add up to 180. Where it splits, those two angles in between are going to add up to 180. So on this one, I can take these two pieces and I can add them up. So I'm going to write it down here. Negative 9x plus 15 plus 2x plus 95 equals 180. All right. So negative 9x plus 15 plus 2x plus 95 equals 180. Hopefully I did that right. Yep. And this one wants me to find the measure of YXF. Y to X to F. That's this piece. So if this one and this one were the same, then this angle here and that angle we're looking for are the same. So I can take that value and I can plug it into this because I know this little piece here also is not negative 9x plus 15. So I can use that expression to find the measurement. And number 10 is misnumbered. This should be 10. Here's the rule. So just like in this one, you don't have to move anything here though. This piece and this piece add up and equal 180. You're finding LED. You're finding the measure of this piece in the end. So you're going to solve for X and then find what that angle right there measures. Okay, so let me zoom out where you can kind of see everything that I wrote. Hopefully, yeah, I think I can get it all on there. Okay.